Okay, here is homework problem number 5. Classify each of the following statements as a tautology, a contradiction, or neither. If it is neither, find a simplified expression equivalent to the given expression. Justify your answer in each case by applying algebraic rules of logic. Okay, so for part A, what I'm going to do is I'll just copy it, Q or 1. With an or statement, all you need is one of them to be true for the whole thing to be true. So the whole thing is true. So it's a tautology. Okay, that's always true because it only takes one of the two to make it true on an or statement, and one of them always is true because it's a 1. Okay, so P and 0. Well, this one's very similar. It takes both sides being true to make the and true, and that's the only case where the and is true. And if we have a false on one side of an and statement, it's always going to come out to be false. And so this is a contradiction. Okay, part C, it says not the case that P and 0. And from part B, we know that P and 0 is a contradiction, so this is not 0, which is 1, which is a tautology. Finally, part D, let's see here. P or not P, and Q or not Q. Okay, I recognize this because here we have one of those forms that's in that big table. And we just know that either P is true or not P is true. Same thing with Q. These are both tautologies. The left, P or not P is a tautology, and Q or not Q. So I have 1 and 1, which is always true. So this is a tautology. Okay? So none of them were neither in this one. Now let's go to problem 6. I think I might have one or two that is neither here. Classify each as a tautology, contradiction. Justify your answer in each case by constructing a truth table. Okay, so this one we're going to construct truth tables. So I'm just going to go ahead, and for part A, I notice that it only has P and Q, only has 2 variables, so n is equal to 2 for this part. And so I'm going to make my truth table with just a P and a Q in it. And I'm going to go ahead and do this in a couple of steps. Well, I'll do if P then Q, and I'll go or if Q then P. And I think I can fill this in here. I have 4 possibilities. And if P then Q is true whenever P is false, and the only time if P then Q is false is when I have a true premise and a false statement. If I have true premise and true premise and false conclusion. If I have a true premise and a true conclusion, it's also true. Now I'm going to evaluate if Q then P. This one is only false if the premise, which is Q, is true, whereas the conclusion, which is P, is false. This is the only case, this row 2, when that one is false. So I have 1 and 1 and 1. And now I have 2 columns here, and I'm going to do an or between the 2 of them. And so it only takes one of them to make it true. And so this is a tautology. Okay, either P implies Q or Q implies P. And this is kind of a funny thing. If you just choose P and Q to be any 2 propositions, either one implies the other or the other way around. One of those is always true, and that's sort of a consequence of the fact that we call the implication true whenever the premise is false. Okay, it's kind of a funny thing there, but according to our rules, that's the way it is. Next one is P and Q or This is also an n equals 2 case, so I'm going to go ahead and jump directly to the truth table here, or not P and Q. Okay, and there's a parenthesis here. Okay, and so I'm going to fill in my 4 rows, and now I'm going to do P and Q first, and that's only true when they're both true. P and Q is, again, oops, I messed it up here. Where's my eraser? Yeah, I think it's true when they're both true. And now I'm going to negate P and Q over here, and I get 1, 1, 1, 0. And finally, I'm going to do an OR between these two columns, and I'm going to get a 1, 1, 1, 1. So this is my final answer, and it's a tautology. Okay. Okay. Does that make sense? P and Q, not P and Q, and I'm doing an OR between those two. Yeah, I guess that makes sense. Let me do let's see, I need to have a new page here where I do part C. And part C is P implies Q and P. So this is, again, the case n equals 2, P implies Q and P. Is that right? P implies Q and P. Yes, it is. So I'll go 0, 0, 0, 1, 0, 1, 1. And if P then Q is only false, we have a true premise and a false conclusion. And P, I'm just going to copy the pattern 0, 0, 1, 1 here. And now I'm going to do an AND between those two columns. And it's only true in the last case. Okay? And so tautology, contradiction, or neither. If it's neither, write a simplified expression equivalent to the given expression. Justify your answer. Let's see. This is, in fact, so this whole thing here, this whole expression, if P then Q and P, evaluates to 0, 0, 0, 1, which is the same thing as the AND statement. It's only true when they're both true. And so I can write P and Q and write 0, 0, 0, 1, and that's the same as this. Hence, those two are the same, and I can write P implies Q and P is equivalent to P and Q. So it's neither, and here's the simplified statement. Okay? Finally, part D. Let's see if I can, oh boy, how am I going to remember this? You know what? It's easy. I have OR statements, and I have 4 things in between 3 OR statements, and look at the pattern. It's P and Q, P and not Q, not P and Q, and not P and not Q. In other words, I have all 4 combinations of P and Q being true and false. Okay? And that should give you the idea that that thing is true. It's kind of hard to make the truth table fit here. Let's see here. I think I need a new page. Okay. So we have P and we have Q. And we have this giant thing, P and Q, or P and not Q, or not P and Q. I'm doing all 4 combinations, or not P, or, oops, and not Q. So the first one says they're both true. First one, second one says P is true but Q is false. Third one says P is false but Q is true. And the fourth one says they're both false. And we can just look at that and say, look, that takes care of all four possibilities of P and Q. And so this thing's got to be a tautology. But let's go ahead and double check that with this truth table. P and Q is only true when they're both true. P and not Q is only true when P is true and Q is false. Right? If P is true and Q is false, right. Here, not P and Q is only true when Q is false. No, when P is false and Q is true. So this case, row 2. Finally, not P and not Q is only true when they're both false. And now we see that we have an OR statement amongst all of these things. And basically we're going to use the rule that if P or Q or R or S is true whenever at least one of them is true. And you can see here now that in every row there's exactly one of them which is true. Okay? Here, 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 or here. In other words, this is a tautology, and obviously reduces to 1. And I'll stop this video here.